Hello, welcome. This will be my Serengeti report about jackal movement patterns, day versus night, and across seasons. So, what are jackals? They are also known as genus Canis. They are medium-sized carnivores and they're known for their adaptability, hunting behaviors, and nocturnal activities. And jackals, they rely on nighttime, so they can reduce their competition and avoid larger predators like lions, hyenas, and leopards. And they do this so they can have access to their smaller prey like hares and rodents. And so jackals, they also play an important role in the ecological position right here, and because they act as natural regulators for small mammals populations, specifically during the winter months since their food is less available. So, in my research report, I wanted to research jackal movement and their daily seasonal patterns, and I'm determined to understand why jackals move more frequently at night than during the day and how these patterns are changing across seasons. So here's my hypothesis. If jackals are moving during the night more than the day, then they're hunting more often because they're seeing less from their predators. And here's my no hypothesis. There is no difference when jackals are moving during the day or night. Alright, so let's go to my methods. So to test my hypothesis, I focused on the variables that describe jackal activity patterns. So I got their daily activities, which allow to track them 24/7, their annual activities, which track them yearly, and their spatial distribution, where we can see what's happening in Serengeti and around the map around there. And here's some additional information. I will be using the year 2011 in my annual activities, and in my spatial, no, not spatial, in my annual activities, I'll also be doing October and March during the winter and spring era. And so in my spatial distribution, I'll be filtering the grassland with trees and using the southern Serengeti area. Alright, so if my hypothesis is correct, there should be a clear pattern in the daily activity graph showing that jackals move more in the night than during the day. And so this will appear as like higher nighttime activities and lower daytime activities for them. And so for annual activities, uh, jackal movement should increase during the winter and spring. And in the spatial distribution, it should show clusters of jackal detections in areas where night hunting is more common. And if my no hypothesis is correct, in daily activities, it will show similar activity levels the entire 24-hour cycle. And in the annual activity, it should show no major seasonal peaks. And in my spatial distribution, it should show no meaningful activity patterns. Alright, so here are my results. In figure 1, this is my graph right here. It shows the time in 24 hours. So we can see that jackals are more active during the night than the day. Alright. In figure 2, this is my annual activity. This graph shows the activity of all the months of the year, showing off spikes of when they are most active. And we can see that around March, they start, or March, February, around there, we can see that, they're spiking high because they're probably searching for food right now because they're running out of food. And in figure 3, I use this to illustrate where jackals were detected throughout Serengeti. And so if it's more red, there's more jackal frequencies and more population there. And so we can see that in the bottom there's a lot of jackals there. So in conclusion, based on the 3 figures I analyzed, my hypothesis was supported. The data show that jackals are more active at night than during the day, and their movement increases during winter months, right? And so in figure 1, I demonstrated a clear peak nighttime activity, and so this indicates that they're more active during the night. And so in figure 2, I show that jackal movement is higher when it's in the cooler months, and so this means that they're trying to look for food. They're trying to get their prey because they have less available food. And so in figure 3, it's revealed that jackals tend to cluster in specific regions of Serengeti. And so, this suggests that they're likely to contain more prey or offer great protection from larger predators. Alright, so here's my biological explanation. The patterns for the jackal behaviors, they are nocturnal animals, and so they avoid larger predators while accessing small mammals like rodents and hares. They have nocturnal activities and nocturnal activities reduces human encounters. So during the night, they're not encountering their predators. And so jackals, they move more during the winter months to find more food, and jackals regulate small mammal populations. And here's my caveats, I don't know how to say this, of this analysis. So there are several limitations, and so first of all, cameras, they only capture what's in front of them, right? And so maybe there was some jackals behind the trees or behind the cameras, right? And so sometimes we're not really sure if we got the best data, but this is just the right amount of data that we have for now. So secondly, jackals may travel in pairs or small groups, and so my data set treats each detection independently, so it can influence how movement patterns appear, right? And so mating periods may also be affected because we don't know when they're gonna mate, right? And so yeah. Alright. And proposal for future research. So if I were to research more, I would definitely do more detailed tracking methods like a GPS collar, right? And so I'll probably put some collars on jackals, and also the second one too, track predators and prey to see if they interact or influence jackals, right? And so maybe we can also put GPSs even on our predators to see how many of them encounters them, how many of them attacks or just leaves them be, right? And so my third one, collecting prey seasons, right? Yeah, so here's my summary. After all my feedbacks I got from my peers and TAs, I made a lot of changes throughout my draft. I added reasons to why I came up with my answers because I would just leave it as it is, right? And then I would connect figure 3 more into my hypothesis because my peers couldn't really understand why it was there. It was just kind of random, so I added more reasoning, and so that kind of helped me figure out why I need spatial distribution. And so lastly, I rephrased my hypothesis more because at first I didn't add the if in the beginning, and so it kind of sounded like a statement rather than a hypothesis. So yeah, so thank you for listening.